So now let's discuss the next part of the question. It says that what does a toroid consist of? Find out the expression for magnetic field of a toroid for n turns of the coil having the radii r, small r, and carrying the current I. Show that the magnetic field in the open space inside and exterior of a toroid is 0. So toroid basically is a hollow circular ring on which a large number of insulated turns of metallic wire are closely wound. So let us just make a hollow ring. So that's one. So basically this is hollow. So now the wire in the toroid is something like this. So the current is entering and then it is like in the form of a helix. The wire is closely wound on this ring, which is hollow. So that's the shape of a toroid. So the current is entering from one and exiting from the other end. So the magnetic field at a point is given by the tangent to the magnetic field line at any point. So now again, to have this derivation, let us again consider a toroid. So let's say in the inside point of it, we have to find out the magnetic field. So if O is the center, let us take this sphere that we are considering, or this circle. So it is of radius small r. Okay, so the length element is going to be going like this, and that's a small dl element that we are going to consider. So the b is our b is going to be in this direction as well. So we are knowing that the closed integral of b dot dl, b is constant, it would be taken outside. So the integral of dl, so what's an integral of dl? It is going to be equal to the circumference of the circle, that is 2 pi r. Now according to Ampere's circuital law, b dot dl is equal to mu naught times the net current enclosed by the circle, that is the total current enclosed by the circle of radius r. So we can write it as mu naught into total number of turns into I. So mu naught into n into 2 pi r into I. So let's just name the first one as 1 and this one as the second. So we are comparing, that is the LHS of both of them are the same. So we are going to compare both of them. That means b into 2 pi r is equal to mu naught n 2 pi r into I. So cancelling the 2 pi r's, we are left with b is equal to mu naught I, where n is the number of turns per unit length. So for any point inside the empty space surrounded by toroid and outside the toroid, magnetic field is 0 because the net current enclosed in these spaces is 0. So we can say that for any point that is outside or any point inside the toroid, the magnetic field is going to be 0 because there is no current in these places. The current is just existing inside the toroid. So thank you so much for your time. Have a great day. Bye bye.